In this video, I will give a brief introduction to logic, an example of valid reasoning and an example of invalid reasoning, also known as a fallacy. Logic is the science of reason. The word logic derives from the Greek logos, which means word, reason, thought, speech. I think the Greeks believed that it wasn't enough to just think. One had to express these thoughts with speech or writing. Indeed, this was a key part of the classical education system and enabled the educated to participate in a dialectic, the debates of ancient Greece. Understanding logic will help you to reason. You will understand and identify valid reasoning, but also bad or invalid reasoning. A good understanding of logic is essential in formal debates, but is also useful in everyday life. A syllogism is a fancy word for a certain type of argument, and by argument I don't mean shouting at someone, I mean presenting a point of view. A syllogism is a form of deductive reasoning, and this simply means it is a step-by-step process to arrive at a conclusion. Let's look at a simple example. It begins with a premise. A premise is just a statement that we assume to be true. This assumption is important because if the premise is wrong, then the whole argument is probably wrong. If the premise is correct, then we move on to the next statement, which is also a premise. There may be many premises before the final statement. Premise might actually be an observation or test. If so, it should be fair and objective, because just as with the first statement, we have to accept that it is true in order to move on. The final statement is the conclusion. This is the logical answer that you arrive at when you go through the argument. If the reasoning is valid, then the conclusion necessarily follows on from the previous two statements. Now let's look at an example. This example has a fancy Latin name, Modus tollens. The name is not important. It is basically a simple type of argument using deductive reasoning. It begins with a premise. If P, then Q. This means if P is true, then Q must also be true. Another way to think of it is that P causes Q, so if P happens, then Q must also happen. The premise is assumed to be true. The second statement is also a premise, not Q. This means that we know Q is false. If we assume this statement is correct, we can move on to the final statement. And the final statement is the conclusion, therefore not P. So the conclusion is P is false. Altogether, if P, then Q, which we assume is correct, and not Q, it therefore follows that P is false. P must be false if we assume the first two statements are correct. If this feels confusing, a concrete example might help. The example I am using involves an airport, specifically this one, which is London's Heathrow Airport, a major airport some 14 miles to the west of central London. Heathrow has 4 terminals, numbered from 2 to 5. If you are lucky enough to fly from Heathrow, you need to ensure that you go to the right terminal for your flight. Now, I should point out that following the global reduction in air travel due to COVID, this example no longer works, so you'll just have to pretend the year is 2018. Now that you know how airports work, let's see this example of modus tollens. The premise: if I am flying from Terminal 5, then I must be flying with British Airways. We can assume this to be true. When Terminal 5 opened, it was called the home of British Airways, and this airline was the only airline using the terminal. The second statement: I am flying with Virgin Atlantic. I have a ticket from this airline, so I know I am flying with them from Heathrow. The conclusion, therefore I am not flying from Terminal 5. This reasoning is perfectly valid, and the conclusion is correct. You are not flying from Terminal 5. However, this reasoning is not entirely useful. You do not know which terminal you are flying from, only that it is not Terminal 5, but there are 3 other terminals. Which leads us to a fallacy. A logical fallacy is an example of bad or invalid reasoning. The fallacy we will look at is called asserting the consequent, which sounds a bit fancy even though it is not Latin. It is very similar to modus tollens, which might explain why people make the mistake of using it. So let's have a look at its syllogism. The first statement is exactly the same. If P, then Q. If P is true, then Q will also be true. P causes Q. So we assume this to be true and move on to the next statement. The second statement is the opposite to that of modus tollens. Here we state that Q is true, and if we agree that Q is indeed true, we move on to the conclusion. And the conclusion is, therefore P is true. Look at that for a moment. Where do you think the fallacy lies? The final statement, the conclusion, is what makes it a fallacy, because observing Q says nothing about P. It is possible, for example, for P to be false and Q to be true, and it is this scenario that makes the argument fall down. Let's return to the airport for a more concrete example. So we are back at Heathrow Airport and are wondering which terminal we need to go to. We start with the same premise as before. If I am flying from Terminal 5, then I must be flying with British Airways. We assume this is true and move on to the next statement. The second statement, I am flying from Heathrow with British Airways. I know this to be true as I have a ticket from them for the flight. So we move on to the final statement. The conclusion, therefore I must be flying from Terminal 5. Do you see why this is a fallacy? The conclusion here is fallacious. It is wrong to conclude that you are flying from Terminal 5 based solely on the previous 2 statements. Now, it is possible that you are in Terminal 5, but it is also possible that you are in one of the other terminals. Indeed, before the global downturn in aviation, British Airways used to use Terminal 3 as well. The final point to make on this is that it is also wrong to say that because the conclusion is fallacious, you cannot be in Terminal 5. This too is invalid. From the 2 valid statements alone, we cannot say which terminal we are in, but we also cannot say which we are definitely not in. All we can be certain of is that the flight is from one of the 4 terminals. I'll finish by putting modus tollens, the valid logic, next to the fallacy. You can see how similar they are, but the small difference between them is the difference between being valid and invalid. This fallacy is one that I have noticed people make in many different scenarios. My airport example is the one that I remember the most. Have you noticed people making this fallacy? And if so, what example do you remember the most? So there you have it. In this video, I explained what a syllogism is and how it works. I also explained modus tollens, a valid form of logic. And finally, I explained the fallacy of asserting the consequent, an invalid form of logic. See if you can spot examples of this logic in everyday life.